Hello everyone, this is our first class and today our topic is sets and operations. Uh, in these sessions, we will explore what sets are and how to represent them, how sets relate to each other, key operations on sets, and working with intervals on the number line. First of all, definition of a set. A set is a well-defined collection of distinct objects. These objects are called elements or members of the set. Examples of sets are there. Sets of vowels, as you can see here, A, E, I, O, U. Set of natural numbers less than 5. It's 1, 2, 3, 4, 5, 3, 4. And set of primary colors, red, blue, yellow. And set of even numbers, 2, 4, 6, 8. Here's some key points, and we have to understand that well-defined. What is the meaning of well-defined? It must be clear whether an object belongs to this set. And distinct, each element appears only once. And order doesn't matter here. It can be 1, 2, 3, 2, 3, 2, 1. Okay. And we move our next slide. Here's a set notation. Set mainly denoted by capital letters and element mainly denoted by lowercase letters. And membership, here's the A, elements of A or A belongs to A. And this means A not belongs to A or A doesn't belongs to A. Here's an example. Here's a set A is a 2, 4, 2, 4, 6, 8, and 4 element of A is true cause of 4 is in the set and 5 not belongs to A. It's true cause of 5 is not in the set. Okay, as 2 is a element of A, 7 is not element of A. It's true. And here's a, as you can see, types of sets. Here's a 4 types of sets. It's a finite set, infinite set, empty set, and universal set. Finite set mainly contains an uncountable number of elements. Here's, as you can see, A is equals to 1, 2, 3, 4, 5. And infinite set contains mainly unlimited number of elements. Examples, set of all natural numbers, it's a 1, 2, 3. And empty set is a null set, contains no elements denoted by this symbol or empty curly braces. Example, set of months with 32 days. And universal set contains all elements under the discussions denoted by U. When discussing digits, it's a 1, 2, 3, 4, 5, 6, 7, 8, 9, etc. And representation of sets. There are 2 main ways to represent sets. One is roster method or tabular method, and another is set builder method. Examples, here's a roster method example. Every elements are visible. As you can see here, 2, 4, 6, 8, every visibles are visible. V, red, blue, green. C is a E, I, O, U. And this is a best for small and well-defined sets. As you can see here, set builder method describes mainly the property of elements, and which is x is an even number between 1 and 9. That means it will be 2, 3, sorry, not 2, 4, 6, 8, yeah. And x, here's another set V is X is an primary color. The primary color here is the set, and X is a vowel. That means there is a property of elements. Okay, it describes the property of elements, and roster method describes the list all elements inside the curly braces. And here's another converting between methods. There's a set from set builder to roster. First of all, here is a set builder method. X is a positive integer less than 5. That means it will be 1, 2, 3, 4. Positive integers start from 1. That's why here's a we start from 1. Okay. And here is a from roster to set builder method. Here is 2, 4, 6, 8, 10. Here is a roster method set, and here is the answer. Set builder method is X is an even numbers between 1 and 11. Or we can write here X is equals to 2n, n element of 1, 2, 3, 4, 5, etc. Okay. Here is relationships between sets. Yeah, subsets. When we say A subset B, A is a subset of B if every element of A is also in B. Okay, like here's an empty set is a subset of A for N is a set of A. The empty set is a subset of every set, and A is a subset of A also. Every set is subset of itself. And if A subset of B and B subset of C, and then A subset of C also. Subsets relation is transitive. That's why here is A is also subset of C. And here's an example. Let A is equals to 1, 2 and V is equals to 1, 2, 3, 4. Here is I have to change the color. Yeah. Then is A is a subset of B. Here is you can see here A is equals to 1, 2 and B has also 1, 2. That means yes, that is true. Yes, every element of A, both 1 and 2, is in B. Is B element of A? No, cause of A doesn't have 3, 4. A doesn't contain 3, 4. That's why B can't be subset of A. So proper subset and equal sets. Proper subsets. Okay. First of all, we have to know what is the proper subsets. A proper subsets of B means A proper A is a subset of B and A not equal to B, and B has at least one element not in A. Okay, like such as here is A is equals to 1, 2, 3 and V is equals to 1, 2, 3, 4. That means A is a subset of B and A is a proper subset of B because of A doesn't have 4. And here is a equal set. A equal B if and only if A subset of B and B subset of A. Every element of B is in A. Okay, here's an example. 1, 2, 3, A is equals to 1, 2, 3 and V is equals to 3 to 1 and A equal B. Order doesn't matter in sets. I mentioned it before. Here is operation on sets. Okay, Hmm. Okay, the union of sets A and B, right in A union B, contains all elements that are in A or both. Hmm. Properties of a union, it's a commutative. A union V is equals to B union A. An identity element is A union of empty set is equals A. And here is, as you can see here, A union of A is equals to also A. Okay, let's check the example. Let A is equals to 1, 2, 3 and V is equals to 3, 4, 5. And A equal B is equals to 1, 2, 3, 4, 5. Notice here 3 appears in both. As you can see, 3 appears in both, but it is listed only once in the union. Okay, here's the intersection of sets. The intersection of sets A and B, right in A intersection B, contains all elements that are in both A and B. A intersection B is equals to X element of A and X element of B. Properties of intersections. Here is a commutative. If A intersection B is equals to B intersection of B intersection A. And here is empty set property. A intersection empty set and is equals to empty. Identity with a universal set is A intersection universal set is equals to A, and A intersection A is equals to A. Here's an example. Let A is equals to 1, 2, 3 and V is equals to 3, 4, 5. A intersection B is equals to 3. Only 3 appears in both sets. Okay, here's a disjoint sets. If A intersection B is equals to empty, we say A and B are disjoint. Okay, here is a complement of a set. Here is a complement of set. A complement of a set A, right and C. As you can see here, here's a simple C universal set A or A prime A complement. Okay, contains all elements in the universal set U that are not in A. Like as you can see here, C universal set A complement set and X element of U and X not belongs to A. Here's example 1. Let universal set is equals to 1, 2, 3, 4, 5 and let A is equals to 2, 4 and complement set of A. It's a 1, 3, 5. The complement contains everything in U except 2 and 4. Okay. And here is a 2, 4. Yeah, 2, 4. 1, 3, 4. That means 2, 4, 2, 4, 2 and 4. Here's the remind is 1, 3, 5. That's why the result is 1, 3, 5. And it's mainly universal set. Yeah, we can also write like this. That means we have to yeah, you can also say it's minus. Okay. Important properties is a complement of universal set is empty. Is a and example 2 is a let 1 2 3 4 5 6 7 8 9 10 and let v. Here's a 2 4 6 8 10 even numbers, and complement of v, complement set of v is a, here is a, you can see 2 2 4 6 8 and 10, 8 and 10. That means here is a 1 3 5 7 9 will be the answers. Yeah, here is the answers. Okay.